So this week we are still in Unit 7. Unit 7 is all about data exploration, right? And basically we do data exploration in two ways. The first way is just to process the data and visualize the data, right? And that is basically what we have learned in the so far, right? We process the data, we do group statistic, we do the population statistics, and via this group and population statistic, we try to have a holistic, a systematic understanding of the data, right? Statistic visualization. That is what we have done up to this point. Last week we have also used this technique, right, to process the Tafang retail store POS data, right? So you can see that only by process the data, doing statistic and also doing visualization, you can also catch a lot of insight from the data, right? For example, the distribution of your age, the distribution of the area, the most profitable product, the most profitable category, right? You can also see some close analysis. I mean, close analysis. What I mean by close analysis is the insight from multiple variables, right? You can see that which age group is coming in more often in which weekday, right? You can see that some product category or product item are selling better in some age group or in some area, right? Some product are selling better in weekend, and some product are selling better in the weekdays, right? All of this type of information, actually, you don't need specific analytic method, right? Up to this point, we do not teach any of the complicated analytic method yet, okay? Just data processing and visualization. You can already do a lot of things. So don't underestimate the power of data processing and visualization, right? If you can do it right, well, you can answer like 80% of the business analytic problem already. Yeah, okay. Now, starting today, we are going to get into the analytic method. By analytic method, I mean like modeling, like prediction, like clustering, like dimension reduction. Now, don't worry about the terminology if you do not know them yet. But this is what we mean by multivariate analytic method. Multivariate means that it takes care of a lot of variable at a time, right? And analytic method, it means that they are algorithm, right? It's not simply just processing the data and doing visualization. They are algorithm to help us dig into the data and get more insight from the data, okay? That's what we are going to do today, okay? So today we are going to do Unit 7, and we have 4 notebooks. We should be here. But by now you should already have a folder like this, right? You have folder and you have that every unit has a separate order, has a separate folder there, right? So today we are in 07. We are going to do 4 notebook. Maybe we only have time to do 3, but it will be okay, right? Okay. and we will do it by case, right? I don't want to like doing mathematics. Although the analytic method they are mathematically complicated. But nowadays, as long as we are doing analytic in the R environment, we have a lot of package to help us do that, right? So all you need to do is to know which function is doing what algorithm, right? You pull in, you input the data in the right format, and you can interpret the output, and that's good enough, right? Okay. Okay. So today we are going to do like two analytic method. They have to do it together because they cannot be told separately. They are related to each other very, very closely. So one thing is called clustering. What we mean by clustering is we group similar subjects, right? Remember that our data always look like this, right? This is the data frame, right? And I already told you that every row of this data frame represent a subject, right? Represent a unit of analysis, a subject of interest, right? A company, a customer, a product item, a customer group, right? And every column is actually an attribute of that subject, right? The company's revenue, company's profit, company's margin, company's growth rate, company's market share, right? And customer, care about customers, like buying frequency, the last time when they buy, and the number of time that they go to your website, right? The number of items that he have bought, right? That type of thing. What is his or her average order amount, right? So this column, they are the variables, and they are the attribute of the subject, right? That's basically the data structure. And what we mean by clustering is we would like to group the similar subjects, which means in this direction, we want to put similar subjects together, right? So we can manage them group by group, right? For example, you have a lot of customers. The customer have different preference, right? They have different willingness to buy, right? They have different buying behavior, right? So if you can group them by their preference, right? So you can design a product for each of the group, right? Right? That would be a lot better than trying to design a product to fit everyone's preference, right? Because it's a nature that everyone has different buying behavior. Everyone has different buying preference, right? So grouping is a technique that we can group similar subject together, so we can manage them better, right? Okay. Dimension reduction is actually so group clustering is actually work on this dimension, right? And in this direction, in this dimension, we do dimension reduction. Okay. The reason that we do dimension reduction is that if you want to compare a lot of variable at a time, right? We can project the variable when we use ggplot, right? We can map the attribute of the subject as x coordinate, y coordinate, right? Right? Remember that when we do ggplot, right? Visualization is actually just like try to project, try to map the subjects into a space, right? Okay, so you can see them better, right? But what happens if if the dimension that you want to compare is like 10 variable, right? But a 10 dimensional space is hard to imagine, right? Because human being, we can only like see 2 or 3 dimensions, right? More than that, beyond that, we no longer can imagine, and we can no longer see what is beyond 2 or 3 dimensions, right? So if you want to compare a lot of variable at a time, right? you need to do a dimension reduction so that you can observe more than two variables in one space, right? So you can observe more than two variables in one space. Let me give you a example. You'll get an idea of that. For those who cannot read Chinese, who can read Chinese? Raise your hand. I mean, who can read Chinese? Raise your hand. Okay, it's still better. But I will explain this, right? Okay. You know what it is, right? This is the map of Taiwan, right? Okay. So, you know that in next month we will have a referendum, right? 公投, we will have a referendum to decide whether we want to import pork from United States, whether we want to like use nuclear power plant, right? That referendum, right? Okay. So this is actually the last time when we do the referendum. This is the record, right? In the last time when we do the referendum, we have like a number of 10 subjects. Okay, we have 10 referendum subjects. Okay, and right now this map, actually I actually use color to represent the ratio of agreement, right? The green color means higher agreement, right? So for in this topic, we will see that the highest, the mountain town, people who live in the mountains, they tend to have a higher agreement, right? People who live in the city, they tend to like don't like it, right? And for this referendum, topic the 15th, you can see the opposite situation, right? Okay. Now this map is good. It's interactive. You can like zoom in, zoom out. You can like click on you can see the detail, right? You actually can see the detail of the ratio of agreement on every town. This is called the 6 metro, right? These are the northern metro, the central, and also in the South Taiwan, right? So this is the metro area. So these are the district. Every color area is actually a district, right? So and if I click on it, I'll see the number of agree. Okay. The data is quite detailed, right? And I actually can select whatever case I want to see, right? Okay. But the problem is, if I use this plot, I can compare up to 2 variables at a time, right? Isn't it? I mean, every county is a record, right? Every administration area is yeah. Consider it in the data point of view, right? This data actually say that we have 10 referendum cases, and we have a lot of like in Taiwan we call it 区, district. We have district in each of this metro area, right? So we have a total about 200 districts in the metro area, right? So it's a 200 times 10 matrix, okay? 200 times 10 matrix. Right? Now I want to compare this 10 variable in all of the 200 counties. How can I do that? But I do it this way. I can only see the 2 variable at most, right? Yes, I can open up like 10 windows there, but imagine that if I like open 10 panel and like each panel a case, can you see the systematic structure? Can you see the systematic pattern of the voting behavior? It's difficult, isn't it? It's detailed, but it's difficult to see the structure, right? Now let's take a look at this. Now this technique is dimension reduction, right? Let me. So every arrow, every line segment is actually a case, okay? Okay. So I I kind of map the 10 cases into a two-dimensional space. Okay? If you have 10 cases and you want to like plot them in the if you want to map each case into a dimension, then you have a 10-dimensional space, right? Like 10-dimensional space is out of our imagination, isn't it, right? So dimension reduction is I try to reduce the space, right? I reduce the 10 dimension into 2 dimension, okay? So I can plot it in a 2-dimensional space, right? Now the first thing you want to consider is how much information. When you do this dimension reduction, some information is lost, okay? So in this case, in this direction, it retains 53.5% of information, and in this direction, it retains 30.1, right? So in together, in this two-dimensional space, it actually captures about 85% of all of the information inside the 10 variables. Okay, so dimension reduction is to compress high-dimensional data into low dimension and try to avoid data loss. Okay, so only by sacrificing 50% of the data, I can actually plot the 10 variable in two-dimensional space. You get the idea? See, originally your data frame is like back to this area, right? So this is the district, right? We have 200 district here. Now this is the 10 case of referendum, right? This is the 2018, so I have the data, right? I have the data. So now if I want to compare them, right? In a systematic way, I want to compare them. And I want to compare the 10 variable at a time, right? Okay? What is your choice? If I use ggplot, I cannot do that. Because ggplot can only like help you do the two-dimensional mapping, right? Isn't it? So there's a technique called dimensional reduction. Dimension reduction, right? There's a tool. You don't have to worry about how to do that, right? There's a tool to help you do this, right? So you have to compress the 10-dimensional information into 2 dimension, and only loss, in this case, only lost 15% of the information, right? Okay. Now you can see that the cases that group together, they have a very high correlation. Do you know what is correlation? You know it, right? Correlation means that the variable tend to like move on the same direction, right? So we can see that actually the 10 referendum, 10 cases, actually can be grouped into 4 groups, right? The variables, right? Now the best thing is like this. I can see this is the Taipei city, right? And this is the Tainan city, okay? The yellow color is the Tainan city. And the pink color is actually Taichung city. Okay. Now I can see a 200 times 10 matrix, very systematically, very structurally, right? See, so the technique that we are going to teach today, right? The data is the same. The data is the same, right? But it help you to observe the, like, if there are too many points, you cannot see the structure, you cannot see the pattern, right? So we can group them, right? We can group them by existing variable, or we can group them by similarity, right? Okay. So in this case, I can describe the result. I can describe the voting behavior of the 6 metro, right? For the last time, right? This is the 2018 referendum. I can describe it in one picture, very concisely and very systematically. You can see the pattern very well, isn't it? Right? So this is the reason that we want to learn algorithm, right? We will not spend too much time on the algorithm. I'll help you how to use the tool in R to do this, right? In business environment, okay? So that's what we, these two things what we want to cover today, okay? I mean, beyond simply processing data and visualize them. Now we are going to go into the area where we want to apply some analytic algorithm so that we can compress the data, right? See, clustering and dimension reduction, they compress the data, right? They reduce the data. When you reduce the data, you lose information, right? We sacrifice some detail and try to get a systematic, holistic view of the entire system. That is the reason that we want to do dimensional reduction and clustering, right? And we want to do that in cases, okay? The 4 notebook that we're going to go through, I will teach you how to use it, okay? Any problem? By the way, I look into your, like, you have a midterm survey, like last time, right? Last week you have a midterm survey. I saw that one of the, some of you have some comments, and some of you like feel like say that complains that the assignments are too difficult, right? Right. Some of you do say that, right? Well, that's good. That's good, right? Just say what you feel, right? Assignments are too difficult, but what I want to say is I actually already reduced the amount of of assignment by 1/3, right? Maybe I will reduce it. I will further reduce the assignment, or I should make it easier for you, okay? But the point I want to say is that that group assignment is not means to do it by yourself, right? In the assignments, there are something that I do not told in the class, right? If you do the assignment, you will find that, right? So that assignment is not designed to for you to do it at home, right? It's not homework, okay? You need to get together, right? Discuss and utilize the collaboration learning time, right? We have 2, right? We have 2 collaboration learning time, right? To do the homework correctly, okay? To do the assignment correctly, I should say so. Okay, so try to get together so you will survive, okay? If you try to do the homework, do all of the homework all by yourself, even it's your personal assignment, it will be very difficult, I would say so. Okay? Alright? And that's why we have the office hour, we have the collaborative learning sessions to help you, right? Okay. Business analytic you have a lot to learn, right? So and I really don't want to sacrifice the important thing that you should learn in this class, right? So some of the material I actually do not have time to teach everything in the classroom, and I put them in the assignment, right? So and remember that assignment does not mean that you want to do it at home, right? You need to bring it to school, do with your team, or try to utilize the collaborative learning time, okay? That should help you catch up, okay? All right? Okay. See, actually, I saw a lot of people do use the collaborative learning time better, and I'm pretty sure that whoever can utilize the time will have a better learning experience in this class. Okay. The design of this class, um, we are not the first school who offer this class, right? So this class has been offered by the first class, the 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 best business school in the world, like the Harvard, like MIT, like Columbia, like Wharton, right? If you look into their online course, and I encourage you to do so, right? Like each of them, the thing that we are teaching is actually like compatible and comparable, compatible and comparable to their class, right? So I really like to like keep the standard, right? I would like to like give you the same quality of teaching material, the same quality of teaching topic, right? As what I have observed in this top class uh, business school. So if there's something that you don't understand totally, it's normal. I mean, whatever I teach, maybe you can only pick up like 80% or maybe 70%. That is normal, right? The thing that you don't understand, if you do enough case, you will understand one day, right? That's the way to learn programming, and that's the way to learn analytic, right? Okay. If if I teach you, if you can understand 100% what I say, right, then I'm teaching too easily. Okay. So that is the way we design the course. Okay. Now let's go to the cases. Okay. So in the first case, I would like to let me close this. Okay. So this is the first case. I would like to introduce what is clustering, what is dimension reduction. Okay. I using an example. So let's forget about the technical detail to see how it works. First thing. Now we have a data set called wholesales data set. It's already in the data folder, so I just read them in and do some. I have to do a log transformation. Remember that for this monetary type of things, if you do not do log transfer, it was skewed. It was very heavily skewed to the right, right? You have a long tail in the right. So the data actually have like 1, 2, 3, 4, 5, 6, 7, 8. Only have 8 column, right? We have 2 categorical column. So the data is from the wholesales vendor, right? And the wholesales vendor, they provide grocery goods. They provide grocery goods to retailers, okay? So each breaker is a retailer. And we have a total of like about three, about 440, 440 vendors, retailers. I would say that. Okay, so this data is actually the read them in, so it's easier to comprehend. So this is the data. And every row is one of the retailer, is one of the customer of this wholesaler, right? Okay? And all of these retailer, they belong to two channels. You can imagine that they are 7-Eleven and Family Mart, okay? Like they are two chain. And then there are three regions. You can imagine that it's like South, Central, and North area in Taiwan, right? So we have two categorical variable, and so far we are not going to do this yet, okay? We are not using them. And for the rest of the 6 variable, there are 6 different type of grocery, right? They are the number of sales, right? The number of sales, which the amount they bought from this wholesaler, okay? So fresh, right? They have milk product, like milk, cheese, that type of thing. They have grocery, frozen, right? And they have detergent and paper, and also have delicatessen. Delicatessen, you know what that is, right? It's like you know, 茶叶蛋 and like hot dog. Like the thing that you buy and you can eat it in the right place. That's called deli, right? That's called deli. So we have 440 retailer, and we have the number of 6 type of grocery that they have bought from us, right? So this is their buying records, right? And I want to like, if I give you this table, what can you see? You basically see nothing, right? It's too many information that you can see, isn't it? So you need to do something, otherwise you cannot observe it, right? Okay, so now let's go back to here. So first thing, we will try to do some clustering analysis. As I told you, clustering is an algorithm that groups similar subject for easier observation and management. Okay, I group them. So if I can group the retailer of similar buying behavior together, right? I may have a different like promotion strategy. I may have a different like supply chains strategy for them, right? Okay, so clustering help us to do that. But if you want to group similar subject together, the first thing you need to ask is, what do we mean by similar, right? That is the first question that you would ask, isn't it? So what do we mean by similar? Now in the aspect of data and analytic, now we kind of treat every in the type of data analytic, we kind of treat every variable, right, as a dimension, right? So when we say 2 retailers are similar, we mean that their pattern of buying are similar, right? Which means that the difference between their variables are smaller, right? I have 2 retailers, right? When I say these 2 retailers are similar, in a sense, I'm saying that for all of the variable that I care, right, the value of the variable, right, of these 2 retailers are close to each other, right? That's what we mean by similar, isn't it? Right? So you can imagine in this way, if I let's skip the detail and go to this directly, right? Say if I want to group the 440 retailer into A groups. Okay. For example, just an example. If I want to group them into A groups, right, and I want to group them by the number of milk and fresh that they bought from us. Okay. I want to use these two variables to group the 440 retailer into A group. That's basically what I'm trying to do, right? So what can I do? Basically, I can use this milk and fresh, right, as the I can project all of the subject that I want to cluster into a space, right? Into a two-dimensional space. If I only have two variables, it's easy, isn't it? I simply map every subject as a point into a space, right? And in that space, if I only have two variables, I told you that's easy, right? I map it into this space. And the point that are closer to each other in this space, distance is the difference, isn't it? I mean, if I use the variable as the coordinate, okay? If I use the value of the variable as coordinate, right? Then in this variable space, the distance of 2 points implies their difference, isn't it? These 2 points are close to each other. Why? Because they're fresh and their milk, the two variables are similar, right? So in this space, in this variable space, they are close to each other, right? It means that they are similar, right? Isn't it? Okay. So can you imagine what we mean by similar? Okay. Basically, for cluster analysis, this is what we do. Okay. We for simplicity, let's start with two variables. Like, for example, I have two variables called x1 and x2. Okay. For clustering, you need to do the variable has to be numeric. Okay. For clustering analysis, the variable need to be numeric. Okay. So I have two numeric variable x1 and x2. Okay. And the way that I can do clustering is I try to map the subject into a variable space. Okay. I use x1 as the x coordinate. I use x2 as the y coordinate. Therefore, every subject will be projected into a point in this variable space, right? Okay? So variable is mapping to dimension. And the space of this variable, in this space of variable, every subject has a point, right? Now in this point, distance is the same as difference, isn't it? Right? As I just mentioned to you, the reason that these 2 points are close to each other is because that their fresh and milk variable are similar to each other, isn't it? Right? So the distance means difference, right? And the closer they are in the variable space, the similar they are, right? That's what we mean by similar. Any question? Now this is the most important thing about clustering, right? Because for clustering, we want to group similar subjects together, isn't it? So we need to know what we mean by similar, right? Okay. And this is what we mean by similar.
Okay, but like, how about the color?
Sorry?
How about the color?
The color do not mean the thing. It just the different color mean different group. That's what it means.
And then what is good?
You mean where the color come from? There's a default assignment. I simply use the default assignment, right? In R, right? if you do not specify color, now for every categorical value, it would assign a color to.
So this one, the program is assigned for us, right? The color, this color, this color.
Right, this color are assigned by ggplot by default. I mean, for categorical variable, if you use the categorical variable, right, as color, right, by default you will choose a different color for each value of that categorical variable. See, still remember the ggplot? The ggplot is to map, right? To map a column into an attribute of the drawing object, right? Now I mapped color into the group. So, and the group is actually this 1, 2, 3, 4 Y's. This is not actually numeric, right? They are actually category, isn't it? Right? Because I actually create this column as a factor, as a categorical, right? So because it's categorical, so when ggplot them, they give each value a different color. That's it. You got me? I do not specify the color, right? I just told ggplot that I want the color, I want to use color, I want to draw the color according to a factor, a categorical variable, right? And the ggplot, they would, because it's a categorical variable, right? So you would simply give each category a different color, a distinct color. That's what you do, right? So the color do not mean anything. It's just like, it just means distinctive group, right?
So I was confused, like if it's separate, like the channel, or if it doesn't mean that. It's just like.
If you want to separate by channel, you will use color equal to channel. Yeah. If you want to observe region, you can use color by region, right? Okay. But if I do that, the region and the channel, they are not similar, right? Because so far we are grouping similar by similar milk and fresh, right? I'm grouping this, I'm doing grouping with these two grouping variable, right? So this is the basic of clustering. We kind of first of all, you need to choose the grouping variables, right? Okay, so for simplicity, let's start with like milk and fresh, right? So it's only have 2 dimensions, right? So in this variable space, we will see the subject, right? Because we can simply use the variables value as a coordinate, right? So we can map them into them, right? So if we want to do like, for example, if we want to do the at the end, I can actually do all of the at the end, I can actually add at the end, I can actually use the 6 variable to do clustering, right? So if I use 6 variable to do clustering, now you need to imagine that there is a 6-dimensional space, isn't it? Now in that 6-dimensional space, every dimension is a variable, right? Every subject is still a point, right? So every point has 6 coordinates, right? In a 6-dimensional space, every point will have 6 coordinates, right? So the 6 coordinates like map to the 6 variables. Okay. So in that high dimensional space, I can calculate the distance of point, right? And I try to group. I try to do this. I try to group the. There's a mathematical algorithm, right? That try to reduce the within group distance, right? I try to do. They are. For example, if I group them into colors, right, different colors, then ideal clustering is like this, right? I actually group this point together, group this point together, so that they are, so within the group, their distance are small, right? And between the group, their distance are large, right? Okay? There's algorithm that help us do that, and that's called clustering algorithm. You get me? Okay? Okay. So clustering analysis, basically this is what we do. We map. First of all, you need to select a set of grouping variables, right? And that variables has to be numeric. Okay? Has to be numeric. Now in this case, we have 6 numeric variable. Okay? So with this 6 numeric grouping variable, we can map our subject into a 6-dimensional space. In this space, variable map to dimension and distance map to difference, right? And there is an algorithm to help us group the similar subject together so that the subject within the group are similar and subject between the group are dissimilar, right? And that is what we mean by clustering and clustering algorithm. Get it? Okay, let's take a break and we'll be back at 10 after 10, okay?